The next presentation will be delivered by Alexandra Ebert. She's an expert in ethical AI and synthetic data and data privacy technologies and works at Mostly AI as a company. So Alexandra, welcome on stage and please deliver your speech.
Thank you very much for having me. So welcome everybody. Unfortunately, there's no free drone to win here at this talk, but I'm very happy to give you a quick introduction about synthetic data and how it helps with privacy, accessing data for your machine learning projects, even boosting your model performance, and also the role synthetic data plays with responsible AI. But I will start with synthetic data for privacy because this is somewhere where synthetic data originated and why we need it so urgently in the industries today. So, oh, my slides are not yet working. Now they should. Yes, now they're working. So what's the challenge with privacy? As you all know, nowadays we collect much more data than ever before. And of course, this is a treasure trove for analytical and AI projects. But as many of you also will be aware of, regulatory complexity currently is increasing. We have the GDPR, the General Data Protection Regulation, which strictly limits what you can do with data. We even heard from some of our customers in Hungary that 40% of their AI projects don't even take off due to privacy concerns. But it's not only the General Data Protection Regulation. The AI Act and many other acts are on the way, which complicate how easy you can access data and use it for your projects. So what we also see is that besides having so much data available, we actually have a kind of data fuel crisis where all of this data is siloed and maybe can't be accessed by the broad variety of talents within a company. A solution to this is anonymization, because anonymous data is exempt from data privacy laws and can be freely used. But the problem is that legacy anonymization techniques like masking or obfuscating actually don't work in the era of big data anymore. To illustrate this, I put a few pictures on the screen. And as you can see here, on the left, you have useful data, and on the right, you have private anonymous data that apparently is not useful anymore. The problem with anonymization in that degree is that if you want to have useful data, you can't successfully anonymize, and re-identification will always be easy and possible. So you're actually, again, in scope of privacy regulations and have to regard to this data as if it were personal data. And if you use these anonymization techniques to make re-identification impossible, you would be somewhere here on that end where there's definitely not enough utility preserved for your analytical projects. And this is not only a problem with images, this is actually something that holds true for any type of high-dimensional behavioral data set because of the curse of dimensionality and the exponential growth of data in the space and of the fact that we all are quite unique when it comes to our behaviors. So to give an example, thinking of financial transaction data, there's a study out there that showed that 80% of credit card owners could be re-identified by 3 transactions alone. And if you think of how many transactions you do with your credit card over the course of a month or over the course of a year, only having 3 of those available is not really enough or valuable information for your analytical and AI projects. And it wasn't even that the whole transaction was preserved, but only the merchant and only the date of the transaction were revealed. And still it was possible to re-identify over 80% of consumers in this data set. And there are many studies out there showing this for mobility data, financial transaction data, healthcare data, or even demographic information. And it's actually quite well understood in the scientific privacy community that legacy anonymization techniques like masking or obfuscating simply don't work anymore for high-dimensional behavioral data set. And this has the consequence that even though so much data is collected, with legacy anonymization, you always have this hard cap, this hard feeling of how much data you can actually use. And only a few attributes, only a handful of attributes are already enough to render you at risk for re-identification. And this exact problem that anonymization doesn't work anymore, neither to protect privacy nor to preserve the utility, particularly the degree of utility that's needed for analytics and machine learning projects. That's the reason why synthetic data for privacy and for anonymization was created. If you haven't stumbled across the term of synthetic data, be aware that synthetic data is not a clearly defined term. There are different degrees of synthetic data, and actually the term itself has been around for a few decades now. But the type of synthetic data that's so valuable for privacy protection is actually AI-generated data. And this is easiest explained with images. If you look on the images here that you see on the left, I'm sure, even though I can't see anybody right now, that you would agree with me that the people here look super realistic, like real human beings. But you might have guessed it, they're completely synthetic. Nobody here in the pictures has ever existed before. The pictures here were taken from a research project on synthetic faces, synthetic images that was conducted by NVIDIA. And there they trained the algorithm on hundreds of thousands of human faces, up to the point where the algorithm really understood how a human face looked like. So it learned the logics of where eyes are positioned, how big mouths and noses are, which skin tones and with hair colors humans usually have. And then once this whole training process was completed, a completely separate generation process was initiated. So by the press of a button, you were able to generate hundreds of thousands or even millions of different human faces that, like the ones here on the screen, look super realistic, look super real, but have never existed before. And it's created from scratch. So it's really like drawing something from hand and not taking, let's say, the eyes of person A in the training sample, the mouth of person B in the training sample, and shuffling everything together to create what you see here. No, it's completely from scratch. It's created from a deep learning algorithm based on the distributions and statistics and information learned from a training data set. And this is synthetic data. It's fully representative, it's highly realistic, but it's fully anonymous. And even though pictures help you to understand the concept, we at Mostly AI, we do the same trick for structured data, business data. So we work a lot with banks, insurances, telecommunication providers, and even public sector organizations. The process works like this. We are not a data provider or a data processor. So we give our software to, let's say, a huge bank, and they use their production data and let our deep learning algorithm train on this production data, up to the point where the algorithm automatically extracts all the patterns, the correlations, the time dependencies. And then again, in a completely separate step, this technology can be used to create new synthetic customers that all contain, or where the whole data set contains the same statistics, the same time dependencies, the same patterns and distributions, just in the original data set. But there's no one-to-one relation between a synthetic customer and a real customer. So you could query this data, you could use this data for your machine learning project, and you would get the same answer, but there's no data point in there that could be re-identified and could lead back to the original source in this data, or to the original subjects that were the source for this training data. And this helps you to actually achieve something that was not possible with legacy anonymization before. With synthetic data, you can grow with the amount of data that you collect about your customers, because nowadays it was not like back then when we had small data sets of demographic information with maybe a handful of attributes for our customers, but many companies have hundreds or even thousands of attributes stored per customer. And while no matter how large your original data set is with legacy anonymization, you will never be able to preserve more than a handful of attributes. With synthetic data, you can preserve nearly all of the information and unlock it for safe access and for your machine learning projects. And this leads us also to the benefits of synthetic data. What our clients achieve with it is that they're significantly faster in accessing data for the machine learning project. So from large enterprises, we oftentimes hear it takes them weeks or in some cases even months until they can access the data. With synthetic data, they can anonymize any kind of data in a matter of a few hours or a few business days. Plus, it eliminates the privacy risk. It's not possible to re-identify your data subjects if you have a synthetic data set, because it's a completely separate data source that's generated from scratch. This also can be seen by the fact that synthetic data allows you to upsample or downsample your data easily. So for example, if you had 1 million customers in your training data set, you could generate 10 million, 100 million, even 1 billion subjects all super realistic. Overall statistics would be equal to the original source data set, but everybody in this data set would be unique, would be different, and still realistic on its own. It also allows you to be more accurate because you can preserve so much more information compared to legacy anonymization. And an additional benefit when sharing data, it also allows for explorability. With classic anonymization, traditional anonymization techniques, it was always a request and an approach that was done on a case-by-case basis, where you, prior to your project, had to say which columns you would need to solve your specific task. And then you would get your handful of anonymized data points or columns. With synthetic data, you can synthesize the complete database, the 200, 300, 400 attributes that you have per customer in your data table. And this would preserve the explorability of the data set. Synthetic data also facilitates collaboration because it's privacy safe and can be easily shared within departments of an organization, but also externally. For example, if you want to collaborate on AI projects with specialized vendors or with certain startups, fintechs, insurtechs, or even researchers. Then it also helps to save costs because all of these bureaucratic processes of case-by-case approvals, assessing toxic combinations and making sure that there's no leakage with traditional anonymization can be eliminated and the process can be automated. And it improves customer understanding because for many organizations, once they start using synthetic data, they actually for the first time are in a position where they can understand and see granular customer data that's still privacy safe. A small anecdote here, we still work for one of the largest Central European banks. And when they first started using synthetic data already 4 years back, they found some financial transaction patterns in their data where they told us, well, that's so strange, no person would have that many income streams and that type of spending behavior, there must be a bug in your software. And we told them, we're pretty confident that there's no bug, so please check with the production data. And then they went through all the procedures so that one person could look at the production data, and they came back and reported there are in fact plenty of customers which have super strange income streams and spending behavior. They just weren't aware of that. And so synthetic data helped them to get closer to their customers and understand how they're truly behaving and what they need. If you're wondering what use cases for synthetic data are, it's actually an enabling technology that unlocks data in a privacy-safe way while preserving the granularity and utility of it. So many data projects become possible with synthetic data. Top use cases for our customers, of course, machine learning and AI projects, but also software testing and digital product development. And the third big pillar is data sharing, because so many are interested either in collaborating with startups or also going in the cloud to, for example, make use of all the AI services available there. But also open data projects and many other things become possible with synthetic data. And increasingly now it's also been used for AI governance, AI audits, or it's considered to be used for AI audits and many other fields around responsible AI. Today, I want to talk a little bit more about synthetic data for machine learning, since I assume that this is something that's of particular interest to you. So in general, one of the first questions we get when somebody starts working or hearing about synthetic data is it really accurate? Can I trust this data? And therefore, whenever somebody synthesizes data with our product, he gets a quality assurance report. That is just a baseline check and an executive overview to compare how the synthetic data looks in comparison to the original data. And here you can already see the univariate distribution, or in that case, bivariate distributions, and also the overall correlation structure is super, super similar. But of course, the real stress test for synthetic data's accuracy are machine learning projects. And unfortunately, I can't show you any real project from our customers due to their business secrecy, but I brought a few publicly available data sets. So for example, synthetic data that's used on the adult census data set showed that machine learning that was conducted on the original data set versus on the synthetic data set led to the same performance. I'm a little bit short on time here, so I'll rush through this a little bit, but I want to spend more time on synthetic data for behavioral data, because nowadays it's not necessarily the demographic information, but actually the behavioral data that's so valuable for organizations. And this is something that can be safely anonymized with synthetic data and then used for analytics and AI projects. And here we, for example, you can also find this on our blog if you want to go in detail there, worked with the CDNow data set, where we had distributions at transaction level. And as you can see here, we picked a few of these distributions, but this is the same picture that you will see for every distribution. The synthetic data super accurately matches the original data. The original data, in fact, here would be represented with a gray line, but you can't even see that in most of the cases because it's just so close to the original. Here we have customer level distributions, which are also preserved. You can see the gray line a little bit, but in general, it matches super, super closely. And our customers report to us that the models they train in practice actually have the same performance power and predictive power as those trained on original data. So it's really already used as a replacement for production data or for other forms of anonymized data to make AI projects at scale a reality. Another thing, if you're interested not in the statistical representatives, but the realism of the data, it's also super realistic if you look at individual levels. So just to give you an overview, we worked for a public sector organization in Austria, which had census data. And there we found synthetic individuals, for example, this Sabrina Leitner here, which was born in 1993 and was born in an area called Rohrbach in Oberösterreich. This person exists roughly 30 times in Austria, but in the real data set, there's no one who has the exact same birth date, year or place, and all are born after the year of 1918. So you could read out of this data this name combination or that first name was some kind of trend in Austria at that time. But what's even more interesting that Sabrina Leitner, that her privacy is preserved, is her husband, who also came from the same area in Austria, and even more interesting, their child. The star here is used for super rare names, which occur not even 30 times, but significantly less frequent, which indicates that this baby potentially had a pretty funky name, which is not that common. But what I'm excited about is to see this. The area where this baby was born was actually not the same as the parents, but a combination of this city name and a city name that is quite next to this city. Because what's happened there is that over the course of time, I don't know when exactly, but somewhere after 2010, those two areas, those two municipalities were combined and merged to one municipality, and therefore the name changed. And even these small subtle things were picked up from the original training data and transferred in the original in the synthetic data. So this shows you how realistic also the individuals look. I also put boosting machine learning performance with synthetic data in the headline of my talk, because this is another area that's quite exciting for our customers. So how exactly can you boost machine learning performance with synthetic data? One area is that you can generate more training data. And there are a few state-of-the-art machine learning models which can really benefit from the increasing training data. I can't go through everything in detail today, but there's also a blog post on this on our website where you can study it in more detail. But just looking at the values on the right, I think you can see how the accuracy improved and the performance. Then you are also able to generate more balanced training data, which is particularly interesting if you have rare incidents like fraud cases. This is the setup of how we did this, but you can also find this on the blog if you're interested to learn more. What I just want you to take away here is that it's also possible to increase performance with unbalanced data set compared to the original data, the unbalanced one, but also compared to some other state-of-the-art oversampling and rebalancing techniques. So if this is something that's interesting for you, please check out the blog post. And if you have any questions, reach out. And I want to also leave you with the information that synthetic data can be used for geolocation data, which is particularly interesting for telecommunication companies, or even now in context of smart city planning, or even COVID disease tracking. So also here you can preserve patterns of granular user groups or granular data subject groups without revealing sensitive information about real individuals. And lastly, I want to speak a little bit about synthetic data in the context of responsible AI. Also, again, because of the time, I can't touch everything. As you might know, responsible AI or trustworthy AI or ethical AI has many different pillars. Privacy is one, security, robustness is one, but also explainability, fairness, and many other aspects. And synthetic data can actually be used in quite a few of these areas. But today I want to focus on synthetic data for fairness. Fairness in artificial intelligence is a quite pressing issue nowadays, which is concerning many boards and C-levels at different organizations we are talking with. Why? On the one hand, because you want to make sure that your AI algorithms are not discriminating, because it's the right thing to do. Then, of course, because there are anti-discrimination laws that require you to do that. And we also have the AI Act, which is currently drafted in the European Union and is expected to come into effect in the next few years, which will also require that you make sure your AI systems treat people equally. And there are plenty of stories that we have already seen in the past few years where equally treating algorithms, fair algorithms, definitely were not in place. On the left, you see a study that was conducted by MIT, which revealed that many of the publicly available facial recognition systems actually don't work properly for dark-skinned individuals and have really subpar performance for dark-skinned females. But also in the context of credit scoring, we have a quite prominent case, which was from Apple's credit card, where suddenly a female user found out that the credit limit she was granted was significantly lower than those of her husband, even though they shared assets and she had a better credit score. So also another case of bias that definitely should be corrected. And then maybe also an incident some of you remember, we have the issue of continuously learning AI systems that could become discriminating over the course of time. And if you remember, Microsoft once launched their chatbot Tay on Twitter, which I think in less than 24 hours became racist, misogynistic, and sexist just because some users made fun of training the system to become like that. So there were some tweets like Hitler did nothing wrong, or many other things that many people wouldn't support or even find offending when reading. And therefore, that's quite a big problem that now is increasingly tackled in the scientific literature, but also in business practices. The reason for biases are manifold. So it's insufficient training data, it's that we as humans are biased, and oftentimes the data that AI is trained on reflects these biases. A prominent case here was, for example, the HR algorithm of Amazon, which learned that for senior management positions, better not to propose any prospects which are female or candidates which are female, because in the historic data it learned that rarely some females were chosen for this position. Then biasing data is also something that's quite hard to do, because removing just sensitive attributes like gender, sexual orientation, or race is not a good option if you look at the current state of the literature. Also, debiasing at model stage is something that's quite difficult to do. And then one other issue that's oftentimes highlighted is that diversity in the AI community is just not as high as it should be. Another component is that fairness actually comes at a cost. So oftentimes when we train algorithms, our goal is to have superpower or to have excellent accuracy. But in many cases, if you want to have a fair algorithm, you have to accept that accuracy can become a little lower. Then more and more regions around the world, so for example, the United Kingdom, but also the European Union, is considering to do AI audits, particularly for AI systems that are applied in high-risk areas like human resources, like access to university, access to credit, financial sector, insurance, and so on and so forth. The huge challenge here is that actually auditing algorithms is quite challenging if you don't have any realistic data, and privacy oftentimes is an issue that you can't share it there. Then another challenge is that fairness is hard to define, because there are so many different mathematical definitions and also societal definitions and expectations of what actually is fair. Plus, Also, that something that's fair yesterday or that's fair when you put it in production might be biased tomorrow, like the example of Microsoft data that I just shared earlier. And then, of course, we have this vicious bias cycle that if you have biased AI, it will quite likely produce data that's still biased, and then this will perpetuate. So as you see, quite a few reasons why AI is biased, and this list is by no means including all the courses, but oftentimes it's the data that's a problem because it's either insufficient, there's some representation of certain categories missing, or we have the historical biases in the data. And this is one of the areas where synthetic data can tie in. If you look at this study, the distribution of hair colors in the real world is seen on the left. The distribution of hair colors that you find in many available gold standard data sets looks like that. And therefore, you can already expect performance for dark-haired individuals does not nearly work or is not nearly as good as those for blonde individuals. And here, more balanced data sets, which would represent each group equally, would lead to a better and fairer performance of the AI system. And synthetic data can help here by creating more diverse examples also of minority groups. I again borrowed a little bit from NVIDIA because the images just make it easier to understand than the structured data we use. But here you can see that different sources were mixed and matched together to create a more diverse data set, which could use or which could help some of the challenges in facial recognition training. But the same concept actually can be applied to structured business data. And we already started working on this 2 years ago, and now we're in the process of working with some of our pioneering and leading customers to do this also in production with their algorithms in the healthcare and other sectors. But it's not only that you can use synthetic data to not only reflect data as it is in production, which is the general use case of synthetic data. In the context of fair synthetic data, you use it to create synthetic data, fair synthetic data that satisfies a chosen fairness definition that, of course, you as an organization choose or that you're required to use due to certain regulations. But it's not only that. It's not only that synthetic data could be used to create data that reflects the world not with its historic biases, but as we as a society would like it to be. There are many more areas where synthetic data helps for fairness. One aspect is that it gives organization the possibility to access and work with sensitive attributes in a privacy-safe way. Because oftentimes those attributes about gender or some other aspects can't be shared and are not made available to machine learning practitioners. And so they name, not even knowing whether they're discriminating or not, as one of the biggest challenges of AI fairness nowadays. And this is something where synthetic data can be used to also use these attributes in the training process and make sure that your algorithm is as fair as possible. It can also be used to overrepresent minorities. And one particularly interesting use case with the developments that we have nowadays is that it can also be used to share privacy safe but still representative data with AI bias auditors. So quite a few areas where synthetic data can tie in. Also, if you're interested to learn more about synthetic data for fairness, we have a blog series out, which is called Fairness in AI and Fair Synthetic Data, which was featured already by Forbes and many other quite popular magazines and gives you a good overview about this topic. Since we're coming to the end, I just want to leave you with 2 recommendations. If you're interested in synthetic data and experiencing it yourself, since December last year, there's an open synthetic healthcare data set out there from the US insurance organization Humana, which gives you granular information of, I think, 1.5 or 1.3 million synthetic customers and their granular healthcare information. And then, of course, you can check out our website to learn more about synthetic data. We also have a community version up at the moment, which is absolutely not on up to date, but should be updated rather soon, where you can also try out synthetic data and see just how realistic, how granular, and how useful it is for your machine learning projects. So thank you very much. And now I'm looking forward to the Q&A part of this presentation.
Thank you very much, Alexandra, and thank you very much all for listening in. I think it was a very exciting presentation. Synthetic data is, I think, in the center of interest of many of us who try to build some AI algorithms, who try to teach some machine to think. We have some questions, and also we have a poll. So yet again, I would like to remind and encourage you to rate the presentations in the poll, and to like the questions in the Q&A, because I will read them according to their popularity. And the first and most popular, according to what I see, is actually coming from Tibor Fodor. He asks, how can you compare synthetic faces with real faces? What is a distance metric? At which distance can you state that the synthetic face is really different from any real examples of the training data? It would be good to display the nearest neighbor of the synthetic face. I guess the nearest real neighbor of the synthetic face.
That's a very good question, but I must confess I'm not that much an expert on synthetic faces, that I'm on synthetic structured data, so I will allow myself to answer this question in regards to nearest neighbors and distance metrics in context of structured synthetic data. Somewhere in the middle of my presentation, I showed the QA report that is automatically generated when somebody uses our software. This not only helps you to quickly assess the accuracy of the data, but it also helps you to assess the privacy. And there we use distance metrics and nearest neighbor metrics to help you assess and check whether there's any chance of re-identification from this data. And basically how these different metrics work is that you look how close synthetic generated individuals are to real data, and then compare this with how close the holdout data that was not used by the model is to the original data that was used in the training sample. So basically you want to see the same degree of variation that you have from a real world holdout data set also in the synthetic data that was generated. And if you achieve this equality of similarity, and that the synthetic data is not too close to the original data that was in the training sample, then you're sure that there is no privacy risk. Of course, there are many other aspects that we also do in our project, in our product to achieve privacy, but this is one of the checks in the QA report that is really one of the safeguards to let you know whether this anonymization was successful or not.
Mm-hmm. Thank you very much. Next question would be from Péter Szilvási. He's asking, synthesized data doesn't actually represent the real data, although it very much looks close enough. How do you evaluate your synthetic data? Is there any benchmark for it?
I would argue that synthetic data very accurately represents the original data. Of course, you don't get 100% of the same information. This wouldn't be possible due to privacy reasons. So to make this more tangible, think of a bank. We're working quite a lot with the banking industry. And if we're thinking of a bank in Austria, then we have customers where significantly less billionaires are in the data set as compared to our US customers. So if a bank only has, let's say, 5 billionaires in the customer base, this information is not included in the training process, because also on group level, the privacy should be preserved of billionaires, or in healthcare, maybe of super rare diseases. So there's a little bit of information that gets lost, but still you're super close to the original data. So also with our metrics, but also with the AI projects that our customers do on synthetic data compared to original data, the difference in performance is just like 0.1% or something like that. And this is definitely something they're willing to take, because otherwise in many cases they couldn't train a model at all due to the privacy restrictions that are on production data.
Mm-hmm. Thank you. Another question from Tamás Illés. What are the thoughts on the synthetic stock market data? Is it possible, given its unpredictability?
I'm actually also not an expert on synthetic stock market data, but I would also sign the concerns here that you can't generate synthetic data, at least not currently, that predicts you the future and simulates all the different scenarios. So what's currently working exceptionally well is having production data and then creating synthetic versions of this data, which give you, as I just explained, not 100%, but super close to the original data level of utility and analytical value. But using this to simulate something that has not happened before, or for example, simulating the pandemic, if you have never seen a corona pandemic, I would be a little bit skeptical that this is working already now.
I see, I see. I think it's an interesting setup. I mean, I see some correlation here with the information that we have. I mean, the information theory metrics of the data as such as if I can create a synthetic data with a very low information data, maybe that's some field of research.
Yeah, I mean, one thing to consider, I mentioned it at the beginning of my talk, synthetic data is not a clearly defined term. We are doing AI-generated synthetic data for structured data, where you have production data or real data as training sample. There is also AI-generated synthetic data, mainly for use cases in autonomous vehicles and training of them, where you have just very little seed data sets and then lots of physical information about, let's say, how a rabbit or a child runs on the street from that angle, that angle, that angle, that angle, with these lighting conditions, rain, yes or no, and so on and so forth. That's, of course, much easier to simulate because we know physics and understand physics of light, rain, and so on quite well, to then have some images or videos available that could be used to train an autonomous vehicle to brake in every incident of a child or a rabbit running on the street. But there it's physics that helps you to generate more data. If you don't really have the rules of how a pandemic is going to happen, yeah, then it's maybe a little bit more difficult to get super accurate data.
Mm-hmm. Thank you. I think we have some more time, so I will put some of the more questions here. One question from Elena Popovic. What is the benefit of real data over synthetic data, and why we still use mainly the real data still? I mean,
well, if we don't think about privacy, there wouldn't be anything better than real data, but it's privacy. And with GDPR, we actually have fines of up to 20 million euros or 4% of global annual turnover, which for large organizations like Google and Co. could be billions in fines. And this is why since 2018, when GDPR went into effect, we also saw this paradigm shift of how organizations think about privacy. Some were more on the forefront in their compliance journey, in the privacy journey, where they immediately put the brake on any project that was working on production data. Even now, there are a few organizations which are still using production data in many cases, but it's really a transition. And in many, many organizations, it's just a stop and they don't have the opportunity to use production data anymore. And synthetic data is the privacy-safe replacement for that. So it's not really an either-or question. There are many situations where synthetic data is the only alternative, or maybe traditional anonymization techniques, but also that is not really a safe route to go with all the re-identification risks that are already very well understood in the scientific and also in the business community.
Mm-hmm. Mm-hmm. Yeah, so I think there's a difference between the only alternative, right? And then in cases where I say that even if I had the real data, it would not be better, right? Do we know anything about that? Cases when even the real data would not be better?
Yeah, definitely. So, I mean, I showed a few of these examples here only with publicly available data sets, but this is also reproduced by our clients with real production data, that with oversampling the data, smartly oversampling the synthetic the data with our generation platform, or creating a more balanced data set or even a fairer data set, this would all be incidents or cases where synthetic data would be better and would help you to get better performance. But also in general, even if you don't oversample or even if you don't rebalance the data set, synthetic data definitely eliminates the super extreme outliers like the 5 billionaires or something like that. So it can also, or you can argue at least, you can also ensure that your model wouldn't overfit on certain peculiar cases because they're not even present in the data anymore.
Mm-hmm. Okay, thank you, Sandra. Let's take one last one, and it's from Jeffrey Westling. It seems like synthetic data is the worst better actual data, or the data that has been made anonymous. Is there a reason why it hasn't been adopted widely, or maybe it had been?
Sorry, I had a small glitch at the first part of the question. Could you please repeat that?
Yes, Jeffrey is just saying that synthetic data is the world's better than actual data. So it's basically in more aspects better than the live data. And if there is any reason why it's not being adopted more widely, or is it already adopted widely?
Yeah, that's a very good question. So definitely it's not yet mainstream technology that's adopted by everybody, but we are getting in that direction. So for example, last year, Gartner, the analytics or the analyst firm, predicted that already by 2024, 60% of all AI training data will actually be synthetic. So more and more businesses are currently looking in that technology. We already are in the synthetic data space since 2017 and are the global leader in that space. And we work with Fortune 100 companies, both in insurance and banking in the United States and also in Europe. But I think one of the reasons why it's not yet that widely adopted is that many organizations are just at the beginning of their data journeys and not even yet at their AI training journeys, and just have to realize what they actually have to do to get use out of the data. And then questions like anonymization, privacy, synthetic data are only the next steps that then have to follow.
Mm-hmm. Thank you very much, Alexandra. So there is one more thing I would like to show you. This is supposed to be you, or a synthetic
sorry, I need to stop screen sharing because even though I have my glasses on, currently the image was just, wonderful.
So this is a small gift from the organization team of the
Very
conference.
nice.
Will be shipped to you via post, so you will receive it pretty soon. And I hope you enjoy being with us. You know that there is the event chat and everything, and also in the networking session you can meet up with people and discuss. So I would like to encourage you to stay with us, and also encourage everyone to start the networking and start the chatting, because although we are not present physically at one place, we are present in a virtual place physically. So let's do that. We will have a longer break now, after like half an hour. And then we will continue with Misha Dollar's presentation. So thank you very much for staying with us. And thank you, Alexandra, once again.